Hello, good evening, everyone. My name is Mahmoud Yunus from Couchbase, and welcome to AI Thinkers. Sorry for the technical issues that we're facing right now. I'm streaming my screen through Faz's laptop, and Faz is just showing it, so you will find it a little bit slow for whatever I'm doing on my laptop. Um, I would like to consider myself in AI as a beginner. I don't want to consider myself as an expert, as Faz has mentioned. And I'm still learning. I would like also to hear a lot from you. If you have any questions on my demo, you can interrupt me in the middle, ask me some questions. Most likely, I will not know the answer. Maybe you are more expert than me. But I have like a very simple demo for you today. It's a known idea from before, ingesting PDF files and understanding the context of the PDF files and ask questions on LLM model and getting responses, proper responses from the LLM model. All right. I was thinking maybe I would just show you first the demo, then I will show you the components, what's happening in the background, what are the tools or components that I'm already using for this demo, and then of course I can show you the code at that. All right. So basically, let me just load any PDF file. I prepare something for the demo. So this is basically, let me just show it to you. So basically, this is just a document about the rental increase in Dubai. So I was just going through my apartment renewal. So I just have to go and just check exactly the percentage increase and so on. This is a very simple document, just a couple of documents, so a couple of pages, and you can see like it has some information about the average or the increase based on your on the average price of the market or average price of the building, how much increase, how much percentage increase you would need for that. So it's quite simple and quite basic. So let me load that into the application. Let me load that into the demo that I have, and then we can ask questions based on that. So I can ask it a question like, if the rent, let me just type with both hands, difference is let's say 11%. What's the rent increase? Oops, sorry about that. So actually now it's running in the background, asking the LLM model, and I should get an answer that if the rental is decreased already by 11% based on the average market, then the increase is actually just 5%. If you ask it something different, let's add a little bit in here. So let's say 31%, press enter. It should be 15%, if I'm not mistaken. Yeah, 15%. So this is basically taking the context from the PDF file that you will see in here. You can see, for example, for the 15%, it's from 31% to 40%. So if the average is that far away from the market price, or that your rent is far away from this far away from the market price, then you have to pay additional 15%. So this is the basic idea. And you might say that maybe the LLM knows about this. So I wanted also to show maybe a private document that that the LLMs most likely will not know about it. So I have, let me just go back in here. So I have a document for my son's tuition fees. So I hope that the LLMs, they don't know about it. It's quite private, but I can just load it into the model and try to ask it questions. So let's see if actually it gets the context from the PDF and give me some information about it if I ask it a question. So let me, first of all, I'm doing some manual work. I need to delete the older document or the older PDF, so I don't have different contexts. So let me just delete everything. I will show you what I'm using. I'm using actually Couchbase in here. And yeah, I have 0 documents. Let me go back into the application. And let me just delete that. And load the other tuition fees document. So let me just show it to you first. So this is it basically. Just a payment confirmation, nothing more than this. And if I go back again to my demo. Let me ask it a question. What school does Hamza attend? Oops. Oh, it got it, even if there is a spelling mistake. So yeah, he goes to this school, Emirates International School. If I want to ask it about like the tuition fees, it will get some information from me from the document as well. Tuition fee. All right. So all of this is actually inside this document. Yeah, here it is. And you can see the amount in here, the name, and so on. I can ask it about the date. I can ask it any kind of questions. And I believe this is actually kind of useful for a lot of companies. Maybe it's not yet common in here that you start to get intelligence from the documents that you have. A lot of companies, they have like a lot of PDFs lying around and they're not really getting any kind of intelligence out of it. And this is something that's simple and easy and straightforward. And it doesn't really cost a lot. It's actually costs almost nothing to run something like this, just to analyze the documents that you have. And it works in this case with PDF files, but of course you can model it on anything. You can load it with images, of course. Maybe you can take a picture of your invoices and so on and start analyzing the invoices and ask questions based on that. This is working only with PDF with text. So if it is a PDF with an image in the back end, inside the PDF itself, it will not work. So you just need to adjust the model accordingly. So what I'm using exactly in the back end? Let me show you the architecture. So I'm actually running the front end, which is called Streamlit. It's a Python framework, basic Python framework, which is good enough for demos. This is my front end, which is actually running on my laptop. And I'm running everything else in the cloud. So Couchbase, the data source that I'm using in here, this is actually running also on AWS. This is the Capella version, and you can actually sign up for free if you would like to use it. So I'm using Couchbase for multiple purposes. I'm using it for the document store, for storing the information that I have. I'm using it for vector search. This is a very important aspect of RAG, of the RAG demo that I'm doing right now. I'm using it for caching. So I'm actually retrieving all the responses from memory. So it's a memory-first architecture. And I'm using it also for eventing. So whenever I'm saving something into Couchbase, I'm saving any kind of document. So I'll start firing an event, fire a function that will call a Lambda function in AWS and so on. All right, so there are two different aspects of this demo. So you saw me upload a PDF. So something happens in the background when I upload a PDF, understand exactly what's inside it. And the second point is chatting with the LLM. So there are two different containers actually running, or two Lambda functions are running on AWS to handle those parts. There's one Lambda function for in ingesting the data, so getting whatever information that I've extracted from the PDF files, and using AWS Bedrock to get the embeddings for those texts that I've already extracted from the PDF. So once I have those embeddings, I just store it back again into Couchbase. And the second Lambda function, it's basically communicating directly with Bedrock. I'm using Llama LLM model, so to get information about the context of the PDF files that I've already shared it with the LLM model. All right. So let's go one by one. Let's go. Take it one by one. After I upload the PDF, basically it gets chunked by a library called LangChain. So who did hear about LangChain before? So I think it's quite common. Everyone knows about it. That's good. So LangChain has already a PDF library that can help us with extracting text from PDF files and just chunk it according to my needs. And if I can just go into the code and show this part. So this is actually the part where I'm just loading the PDF into Pi PDF loader and just chunk it. Where is the num? Yeah, here it is. So chunk it into like 1,000 characters and just give an overlap of 200 because you don't want just to chunk the text and stop it like mid word or mid sentence. So you need to give a little bit of overlap in order to get proper contextual information from the PDF. So once we have the text, it gets stored into Couchbase. So if I can go into my database in the cloud, so it gets stored in here. So let me just go back and forth. So you will see that I have a few documents in here. And let me just do this. So in those documents, you will see that there is the text that I've already extracted from the PDF. And this is the embedding that is generated by my embedding model that is sitting in Bedrock. So once I insert the text, first of all, I insert the text as is. You don't see it in here, but I mean like the text without the embedding is being stored into Couchbase. Then an eventing function that will fire, that will run based on updates, any updates happening on the database, Couchbase collection. It will automatically start calling the lambda function that is running on AWS. So if I can just show you the JavaScript in here. Is it visible? Yeah, kind of. So this is basically a function on update. I'm taking the payload, which is just the text that you have seen, an ID, and so on, and I'm just sending this payload with an HTTP post request. So it's quite simple. I mean, like not too fancy. All right. After that, if I can go back here, this goes into SQS. So we can actually queue it. So if you are having like large documents, hundreds of pages, you don't want the lambda function to hit a rate limit. And so it's a simple and easy idea just to just queue it basically and feed the lambda function whenever it's ready to ingest this data and pass it to AWS Bedrock. And that's it. So basically, this is the first aspect or the first action that happens during this demo. Of course, it goes into Bedrock. I'm using Titan embedding model. Have you heard about it? Are you using that one? Okay, that's good. And that's the first container, the first Lambda function. The second one, which is basically the chat, which is, I think, this is what I've explained before, that I'm taking now the question that I've asked, and I'm also getting the embedding of that question, do a similarity search from Couchbase, because I'm using vector search from Couchbase, and then feed the context, whatever the results that I'm getting from Couchbase, with the question, feed it to my LLM model in order to get proper results for that. And for that, actually, I can show you the code, which is the chat code in here. So basically, again, using LangChain, it helps us a lot in simplifying this. Yeah, all right. Oops, that's a lot. Done.
There you go. Perfect. Thanks.
All right, cool. Now I have to look for the code. Oh, I'm actually on the wrong file. Let me go to chat. And here it is. So this is where I get the embedding first for the question. And I set up the context through like a prompt for the LLM. You're just a helpful bot. If you cannot answer based on the context provided, respond with a generic answer, answer the question as truthfully as possible, and so on. And then I just provide the questions accordingly. And for that, I'm using the Llama 70 billion model that is available on Bedrock. Any questions? This is quite simple and straightforward. But I mean, like, All of this is the idea that, yeah, please go ahead. Yeah, I was going to say that the whole idea is that it's quite a simple and easy demo that you can actually run it without even, it wouldn't cost that much, and it's very simple and straightforward to run. Yeah, please go ahead. Yeah, it can work with that as well. So it requires a vector search, right? Sorry, it requires a vector database. So lots and lots of things to talk about in this question. But yeah, if you're asking, will it work with Postgres? Would it work with MongoDB? Would it work with any other database? I would say yes. It's a vector database. But I'm using Couchbase in here for multiple purposes. As a document store, as caching. So caching is one of the nice things about Couchbase, that you can just cache your requests and your responses in the memory, because everything is served from memory. It's a memory first architecture. And I'm using it, of course, for vector search. So it has its own uses. The discussion whether I should use Postgres or Couchbase, it's a sales discussion, I would say. But technically speaking, yeah, both can work, of course. Yeah, it's Llama 3, the 70 billion model. I didn't test it with large documents, honestly. I mean, like, again, I was just testing like with small documents that like maximum 10 pages, but I didn't try to test it with something larger than this. But it should work. Of course. Now, if you're talking about scaling it, definitely. So what I'm running it right now is like on a single node, like with two vCPU, something very small. But of course, if you would like to scale, definitely that's a possibility. I mean, like Couchbase is a distributed database where you can actually have many nodes, as many as you need, no issues at all. So from Couchbase perspective, of course, you can scale it, and everything on AWS is actually based on requests. So Lambda functions based on requests, so it can scale up based on your needs. And the response is coming from Bedrock. I mean, it should be fast enough in order to handle your requests, because especially we are using SQS, so it can actually Hi. I'm sorry, can you repeat that one? I'm sorry. Okay. Ah, yeah, exactly. So yeah, it's doesn't support OCR. It extract the text as is. So there is another way actually to extract from images, from PDF with images even. So it's kind of the same if you are having like if you have a JPEG file or a PDF file with an image in the background, or an image inside the PDF itself. There is a different way of handling it. But it's the same concept. How to extract data from the file itself. It's just a different method for that. Yeah. So you can just do OCR as you mentioned and extract the data from the image itself, or even feed it to a different model in order to get information from that image if you'd like. But the flow itself stays the same. Yeah. Yes. Let me show you. Yes. So there is a doc and there is a link just explaining what's happening in the background. So it explains everything, and the GitHub link for that. Yeah. So this is the tutorial for that. Yeah. Thank you so much. Thank you. Much appreciated. Again, folks,